All right, here are some examples to go along with the notes that there's a picture in Canvas, but here is a video with some examples. So if I have a formula like this, the format that we use the most in Algebra 1 is mx plus b, y equals mx plus b. Okay, so this allows me to see that this 2/3 is actually my slope. Okay, so I've got a rise of 2 and a run of 3. It's m because it's telling me how to move. My b value in this case is actually the -1 is kind of part of my b value. And that's telling me my y-intercept, where I need to begin. So I'm going to begin my graph on the y-axis down at -1. I put a dot at -1 because my graph is going to intercept the y-axis at -1. Then I'm going to move according to my rise. So I'm going to, or my slope. So I'm going to rise 2 and run 3 and put a dot. I can move multiple times. I can rise 2 and run 3 and put another dot. I can even figure out my pattern back here by doing the opposite, going back 3 and down 2. And so there is my line, okay? I don't have to do a table or anything. I can skip straight to my line. All right, next example, f of x, don't panic about that. It's just another way to write y, okay? It's your output value. So this one, I'm going to begin on +2 on the y-axis, and then I'm going to move with a rise of -1 and a run of 4. So I'm going to rise -1 down, and then we always run to the right, so run forward and put a dot, okay? This one, I don't really have enough room. I could come way over here, but it's kind of going to make my notes messy. So I'm going to go up 1 and back 4. Notice how when you have a negative slope, the line should be decreasing. A positive slope should make a line that is increasing, okay? This last one, again, if I'm thinking about y equals mx plus b, I'm going to begin on +1 on the y-axis. Then I'm going to move. Sometimes we get a little confused when there's only one value for my slope. If I need this to be a fraction, I'm just going to do 2/1. Okay, whole numbers you can always put over 1. So I'm going to rise 2 and run 1. And then I could keep going, rise 2 and run 1, back down 2 and back 1, down 2 and back 1. These should always end up in a nice, pretty straight line because they are linear equations. Now, where we get tricky a little bit sometimes is when certain pieces are missing. So y equals x minus 3. Well, again, I'm always comparing back to that y equals mx plus b. All right, in this situation, I'm going to begin my graph on -3. That's not a problem. Then I'm going to move. Well, I don't really have a coefficient for my movement, for my slope. Well, if you remember back to earlier in the year, anytime a variable doesn't have a coefficient, you can always put a 1 right there. And then if I think about, well, I want a fraction, so I have a rise and a run, I can do 1/1. So I'm going to begin at -3 and then going to move, rise 1, run 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay? And then again, I could back 1, down 1 to fill out my thing. So if it doesn't have a coefficient on x, you just put a 1 there for your slope. The next one, if I think, again, y equals mx plus b, well, this time there is no beginning value. There's no b at the back of this formula. So if there's no b, you can always add +0 onto a problem, right? That doesn't change anything to just put +0 on there. So that means I'm going to actually begin on the 0 for my y-axis. Now I'm going to move according to my slope. So I'm going to move a rise of -4, and I'm going to run forward 3. Okay, don't really have enough room to do another one, so I'll go backwards. I'll go back 3 and then rise up 4 instead of down 4. And I get a nice, pretty connection here. All right, the next one is really different, okay? Because I don't even have an x in this problem. See how these both had y and x, y and x. It was totally okay. Well, now I don't even have an x. So if I think about y equals mx plus b, I can't say that this is a slope because it does not have an x after it. In fact, the entire mx part is missing. And all I have is a y-intercept of 2. So I could say, okay, I'm going to begin on positive 2 for my y-axis. But then we don't have really the information in the equation that we need. Well, if we go back to the notes, the picture notes says, if all it is y equals a y-intercept, and there is no x, the equation is missing an x value entirely, that is a horizontal line, okay? So I can put my dot at my y-intercept, and then I'm just going to draw a horizontal line from there. So from here, just going to go across horizontally. This totally makes sense because if you think about the coordinates all along this dot, okay, I have, let's see, this would be 1, 2, this one would be 2, 2, this one would be 3, 2, I would have negative 1, 2. Do you see how the y value is always a 2 no matter what dot I'm talking about? Well, that's a good indication here that my y is always equaling 2, okay? If I switch gears just a little bit and say x equals 3, here's where you go, okay, well, if I know my formula is y equals mx plus b, this does not match that formula at all. It is way and completely and totally different, okay? X equals a number. Well, just like HOI helped me remember that y was a horizontal line, this acronym VUX can help me remember if I have a formula that's x equals a number, that's going to end up with an undefined slope, and it is a vertical line, okay? Completely different scenario. It doesn't even have a slope at all. So it is dramatically different than all those diagonal lines we were looking at. So I'm going to go and put a dot where x equals 3. Okay, on my x-axis, I'm going to go over to 3. And then VUX tells me that it is a vertical line at that spot. And to prove why this is the case, I'm going to kind of think about the dots like I did on my y line. Well, let's see, that one would be over 1, 2, 3, and up 1. That one is over 1, 2, 3, and up 2. Then I go up over 3 and up 3. I could even do some negatives down here, 3 and negative 1. Again, see how if I want the x to always equal 3, I'm talking about all the dots that are lining up in this vertical line right here. And then just to bring in something from the past, that means that this is actually not a function, okay? Not that they asked that, not that that's really what we're doing right now, but just keep in mind vertical lines are not functions because you're saying the x value always has to equal 3 no matter what dot I go to, x is 3, okay? Hope that helps.